Okay, so far we have learned how to factor by dividing by the GCF, and last time we talked about how we factor by grouping when we have 4 terms. Today we're going to talk about how you can factor when you only have 2 or 3 terms. All right, so as a review, we want to factor this quadratic with 4 terms. So we cut it down the middle. We look for the GCF of the 2 terms. The only thing they have in common is x. We divide by x, and we're left with x plus 9. All right, then we look at the GCF for these 2 terms. Since the first one starts with a negative, we're going to pull out a negative, and a GCF for these 2 terms is 2. So we're going to divide by -2. And we get x plus 9. All right, so you see that both of these have an x plus 9 in common, so that's going to be one of our factors. And then our other factor is what's left, an x and a -2. All right, same thing. We have 1, 2, 3 terms. I'm going to cut it in half. The GCF for the first 2 terms is 2x. They both have a 2x in common. So 4 divided by 2 is 2. X squared divided by x is x. 2x plus 2x is 1. These 2 terms don't have anything other than 1 in common. So 1 is our GCF. And that means that when you divide everything by 1, it's just going to stay the same. All right, we can see that they both have a 2x plus 1 in common. And when you factor out the 2x plus 1, you have another 2x plus 1 in common. So what happens when you only have 3 terms in the quadratic? Well, when we have 3 terms, our goal is to try to write it as 4 instead. So to keep in mind, whatever the number is in front of x squared, we always call that a. This is standard form. We talked about that earlier in the year. The number in front of x is b, and the number that's by itself, the constant, is going to be c. Okay, so we always try to write our answers in standard form. We have to write them in ax squared plus bx plus c. Okay, so if we're looking at this problem right here, the a would be 3, the b would be 5, and c would be 4. In this problem right here, there is no number here, but we know that there's an x squared, so there must be 1x squared. The b is -5, and our c is 3. This time our a is 2. Be careful, our b is -1, and our c is 7. Our a this time is 16. That's in front of the x squared. Oh, there is no x term, so that means since there's none, our b is 0, and our c value is -9. We want to make sure we keep the sign in the front. Okay, so getting back to the original problem, we want to know how we can factor something like this that only has 3 terms. So I know that 4 is a, 4 is also b, and our c value is 1. So the first thing I do is I multiply a times c. So 4 times 1 is 4. And then my b value is also 4. So I'm trying to think of 2 numbers that when I multiply them I make 4, and when I add them I also make 4. So 2 times 2 gives me 4, and 2 plus 2 gives me 4. So the way we make 4 terms is we keep the first term the same, 4x squared, but then we break this into 2 numbers, and the 2 numbers are what we get from those boxes. Okay, so just to be clear, this 2 and this 2 came from these numbers that we picked, but notice I added an x in the back. And then the plus 1 stays the same. Now I have 4 terms, and that is how we factor by grouping. The GCF is 2x. When I divide by 2x, I'm left with 2x plus 1. The greatest common factor for the next terms are 1, and when you divide, you get the same thing. So the greatest common factor for these are 2x plus 1 is what they have in common. And when you factor that out, you're left with another 2x plus 1. So when you have 3 terms in the beginning like we did, our goal is to try to break it up so that we have 4 terms. All right, let's try one more. Okay, so this time we have a 1 in the front. That's going to be our A. Our B is going to be 8, and our C is 12. So the first thing we do is we multiply A, so 1 times C, 12. 1 times 12 is 12. And then B is 8. So we're looking for 2 numbers that can multiply to make 12, but also add up to 8. Well, I know that 6 times 2 is 12. And I know that 6 plus 2 is 8, so that must be my 2 numbers. So x squared stays the same. This middle part breaks up into 6x and 2x. And the 12 in the back stays the same. Now that I have 4 terms, I can break this in half. The GCF for this is x, and when I divide, I get x plus 6. The GCF for these 2 terms is 2. 2x divided by 2 is x, and 12 divided by 2 is 6. So they both have x plus 6 in common. And when you factor that out, you're left with x plus 2. So when you multiply these together, you're going to get exactly what you start with. All right, this time our A is 2, our B is -1, and our C is -6. So A times C, so that will give us a -12. And our B value is -1. So I'm looking for 2 numbers that multiply to make -12, but also add up to make -1. So -4 times 3 is -12. And -4 plus 3 is -1. So we're going to have 2x squared. This is going to break up into the 2 numbers we found, -4x, excuse me, plus 3x, and then -6. Cut this down the middle. Our GCF is 2x. That'll leave us with an x minus 2. All right, if you divide by 2x, you'll have an x left and a -2. Looks like the GCF for the second 2 terms is 3. And that gives us x minus 2. Great, so we can see that they both have an x minus 2 in common. And then the other the other terms that are left are 2x plus 3. All right, our last one. So we have an A. Oh, we don't have another number in the middle, so that's B, and then our value for C is -9. So A times C, 4 times -9 is -36. Sorry, that's a terrible 3. Our B value is 0. There's nothing in the middle. So we're looking for 2 numbers that multiply to make -36, but add up to 0. I think that -6 times 6 is -36, and -6 plus 6 is also going to be 0. So 4x squared goes in the front. The 0 term becomes -6x plus 6x. And then our -9 in the back stays the same. Now we have 4 terms. Our GCF for these 2 is going to be 2x. All right, that makes 2x minus 3. Sorry, this is getting messier as I go. GCF for the next two terms is 3. So 6x divided by 3 is 2x, and then -9 divided by 3 is -3. Oh, good. So I can see that they both have a 2x minus 3 in common. And then our other term is 2x and a positive 3.